Okay, so let's start with a really simple system here. Okay, this is a pulley system, and again, so we have to make some assumptions. So we're going to make some assumptions that there is no friction in the system. So one assumption is no friction. And the other assumption is that the string is massless. Okay? So these are the two assumptions that we're going to make. Okay? So let's come up with a really simple question. So we're going to have, let's imagine we have a mass on this side, and the mass on this side is 2 kilograms. Now let's say the mass on this side is, let's say, 5 kilograms, and we want to calculate a few things. We want to calculate net force. We're going to calculate acceleration, net acceleration, and we're going to calculate tension in the string. Okay, that's what we're going to look at. We're going to calculate the net force, net acceleration, and the tension in the string. All right? Okay. So, just pause for a second. All right. So let's consider there's really only two forces acting on this system, right? There is the weight of this object on this side, and then there's the weight of this object on this side due to gravity. So we can easily calculate that. So what's the weight on this side? It's mass times what? Mass times g. So this side will be 2 times 9.8, which is 19.6 newtons. Okay? On this side, what is it? It's going to be 5 times 9.8, which is 49 newtons. Now, let's think about this for a second. They're both pulling down, and I know that in physics we have signs to indicate, down is one thing and up is something else. So the thing though is, here we don't really want to think about going down or up. We want to think about the rotation of the pulley, okay? So let's think about what, if this mass were heavier, it would pull the pulley which way? It would pull it this way, okay? And we'll call that what? Clockwise? What's that? That's clockwise, right? Okay, so that's clockwise. But what about this one over here? What would it want to move? It would want to move it counterclockwise. So we got to think of, the idea is similar. One way is positive, then the other way must be what? Negative. So we got to think about the rotation of the pulley. So what do you want to do? You want to make clockwise positive? We can make clockwise positive, make counterclockwise negative. So we can say this is positive and this one is negative. Okay? Because when we do our net force, you might get the wrong idea. When we do our net force calculation, you might accidentally add up this and this, because if you look at it, they're both pointing which way? They're both pointing down, right? But you can't think of it that way because it's a pulley. You got to think about the rotation of the pulley. So if we make clockwise positive, we could say, well, okay, this force is positive, therefore this one would be what? This one would be negative. So when we add them up, because the net force, you add up the forces, it would be 19.6 newtons plus negative 49. So what would that be? What is that? Is that 29.4? 29.4, but you notice that it's negative, right? So it's 29.4. Let me make that a little bit better. This is not a high quality video. This is not HD, high definition. So it's going to be, the F net will be negative 29.4 newtons. Again, the negative means what? Which way is this thing rotating? Counterclockwise. So that means that this mass will go down and this mass will go up. Okay? So far so good? Alright, so that's A. We can think about the net acceleration of this system. So we have a net force. How do we figure out acceleration? Well, the acceleration, we go back to Newton's second law, F equals ma. We can say A equals F over what? F over m. Now, in this case, we have a net acceleration. So we're going to use net force. We know the net force here is negative 29.4 newtons. Now, what would we use for the mass? So let's think about these. These two things are connected, right? They're connected through a string. So it would make sense that we're going to think about the acceleration of the whole system. So that would be the whole mass. Okay? So we got to think about not just one mass, but both of them because they're stuck together. So the acceleration here would be a function of the net force. So this is actually should be a net. Is 29.4 over 7. So what is that? That's about 4.3. What is it? 4.2? 4.2. 4.2 meters per second squared. So on this side, it's going to accelerate upwards at a rate of 4.2 meters per second squared. On this side, it's going to accelerate downwards at a rate of 4.2 meters per second squared. Okay? So we have now the net acceleration. So we have one thing left, tension. So let's finish that over here, tension, okay? So, when you're trying to figure out the tension to string, you only really need to look at one of the two sides of the pulley. So let's look at this side, okay, for tension. Let's look at this side right over here. All right? I'm going to redraw this just so we can just focus on that. So we know that we have an object. We know that gravity is pulling it down with a force of 19.6 newtons. And we know that there's a tension. But here's the question. What's actually causing the tension? Right, it's the other mass. Very good. So this is what we know. We know that this thing is accelerating upwards. We know it has an acceleration of 4.2 meters per second squared up. But that was the net acceleration, correct? This is the net acceleration. So we could figure out the net force on this mass alone. The net force is equal to the mass times the net acceleration. The net force on just this object would be its mass. This is a 2 kilogram mass times the net acceleration. Now in this case we can think about, we can just go back to, up being positive and down being negative. So because it's accelerating up, we'll say that's positive. So we'll leave this as positive 4.2. So this object is experiencing a net force of 8.4 newtons up, or positive 8.4 newtons. So now we just go back to a very simple idea. Well, if you think about this object, the net force can be defined as what two forces acting on it. Well, there's this one, right? Which is pulling which way? Up. And then there's this one, which is pulling which way? Down. So we can think of the net force as the tension minus the weight. We have the net force. We just figured out what it is. So let's finish off our solution on this side. Change the color. So we could rearrange and solve for Ft. Because we have this, we just figured that out. We already have this from before. So we could say, well, okay, well, the tension would have to be the net force plus the weight. So the tension would be the net force, which is 8.4, plus the weight, which is 19.6. So what would that give us? 28, right? 28 newtons. Yes? We did. Because look, if you look at the net force, the net force is defined as the sum of the forces. So it would have been Ft plus Fg, but we know Fg is negative, so it ends up becoming Ft minus Fg. Okay? Alright, very simple question with pulley. Let's combine a pulley system with a ramp with, we'll start with a ramp with no incline, so it's not really a ramp, it's just a level, level block. Okay? So let's look at something like this. So let's say that we have a block, and the block has a mass of let's say 10 kilograms, and this mass is 5 kilograms, and the coefficient of friction between the block and this, whatever this is, the surface, let's say it's 0.2. Alright, and we want to calculate, again, same idea, net force, net acceleration, and tension. Okay? So a pulley system, right? So a pulley system. So we're going to assume, again, the pulley is frictionless, and the string is massless. Okay? Alright, so let's first start with what do you think the two forces are acting on this pulley? Okay, well there has to be what here? What would this force be? It would act on this object. So the pulley is separate, right? So what do you think this force would be? What is it? Sorry, Alex? Yep, it's weight. And we can easily figure out what that is, because we know it's just mg. So it's 5 times 9.8. So that gives us a weight of 49 newtons, correct? What would the other force then be in this system? There's only really one other force that's going to affect the movement of this block. And I gave you a hint right here. Yeah, friction. Now, which way would friction be acting? If this block would happen to slide, and if this mass ends up pulling down, that means this block is going to move which way? It's going to move this way, right? So that means friction would be acting which way? The other way. So it has to act this way. We can calculate the force of friction. It's pretty easy. We know that is mu Fn. And we have mu. We know it's 0.2. Now in this case, Fn would be what? It's the normal force, and we know it acts which way? We know it acts opposite, or it's perpendicular to the surface. So here's my surface right here. So it's perpendicular to the surface. And this block is not levitating up or down. So that means that the normal force has to equal what? This force, which happens to be the what? The weight of the block. Right? So the normal force in this case, is the same as the weight of the block. So we could substitute a normal force for the weight, which we know is 10 times G. So we can go ahead and calculate what's the friction. So this is 98. So what's 1/5 of 98? What is that? 19.6. So now we can do the same thing we did before. Look, this block is going to be pulling the string this way, which means if we follow logic, right, the string is going to be pulling on this block to the right, but friction pulls to the left. So if we did our net force calculation, it would be, well, how do you want, if you want to, we can make this way, clockwise, positive again. So we can say 49, because it's going to want to rotate the pulley clockwise. We'll make that positive, which means this force is going to do what? Do the opposite. Friction is going to want to turn the pulley. Not friction can't turn the pulley, but if it could, it would try to turn it which way? Counterclockwise. So we'll make that force negative. So what's our net force? Exactly the same as the other one, wasn't it? Not just a coincidence in this case. So is it the same thing? 29.4? Can you tell me? 29.4, right? Okay. So we have the net force. Now we do the exact same thing we did before. We're going to calculate the net acceleration. Okay? So again, net acceleration is going to equal F net over the mass. We know the net force is 29.4. Again, these things are connected by a string, so we've got to consider the total mass. That would be 5 plus 10. So the total mass would be 15 kilograms. So the net acceleration would be close to 2. What exactly would it be? 1.96 meters per second. Oop, sorry. I don't know why I did that. Meter per second squared. So that means that this object would accelerate downwards at this rate. This object would slide to the right at this rate. Okay? Alright, one last piece then, tension. We can do the exact same thing we did before. So if we consider just this block, we can redraw this block. So we know the block has a mass of 5 kilograms, and it has a weight of 49 newtons. So there's tension in the block, which we don't know what it is, but we know the net force on the block. Because we know the block is accelerating which way? Up or down? We know it's accelerating downwards at a rate of 1.96 meters per second squared. So the block has a mass of 5 kilograms. It's accelerating down at 1.96 meters per second. So this would be, what is that? 9.8, sorry, 9.8. So there's a net force of 9.8 newtons down. That's why it's accelerating downwards. So again, we can go back and say, look, we know net force in this case is going to be the sum of which two forces? Tension and the weight. So it's going to be the tension minus the weight. We could rearrange for tension as then the net force plus the weight. The net force is which way? Down. So if it's down, well, we got to consider our signs here. Down would be negative. Up would be what? Positive. So this is down. So this is actually negative 9.8. And the weight is 49. I'll just finish it up over here. So what's our tension? 39.2. Now, what would have happened if we didn't remember to put a negative sign here? Then this number would have been what? This number would have been bigger than 49. And then would it have made sense? If this is bigger than 49, if this is greater than 49, which way would this object move? It would move up. And so therefore, consider when you solve these questions, use your logic too. Sometimes you make a mistake with the sign. You're like, okay, that doesn't make sense because we know it's going down. So in this case, because it's going down, we know that this has to be negative. So our net force is 39.2 newtons. Okay? We'll do one more. Again, it's a combined question, but this time we're going to have a ramp on an angle. Dun, dun, dun. And we're going to put in friction too. Alright? And this will be the last question. So same idea. We'll have a block. Okay? We'll use the same masses as before. We'll say 5 kilograms. We'll say 10 kilograms. We'll even keep the same coefficient of friction. I think we used 0.2. And we'll have a small angle of 10 degrees. All right? We're going to do the same thing. We're going to calculate the net force. We're going to calculate the net acceleration. And we're going to calculate the tension. Okay? What's different about this question, though? What else do we have to worry about here? Everything. There's also a downwards force, right? Because now, there's another downwards force. There's one over here, but there's also one because this object is going to want to do what? It's going to want to slide down that ramp. It's going to want to slide down that ramp. So let's think about the forces here. We have the weight on this side, which we already calculated before is what? 49 newtons. So we have the weight here. Now we have to consider the force of friction on this side. So the force of friction. And we have to consider the force down the ramp. Now, do you think the force of friction is going to be the same? It's not, because the ramp is on an angle. And if you remember, the force of friction we know is defined as mu times the normal force. But the normal force in this case is what? It's not equivalent to the weight. It's equivalent to the weight times what? Cosine theta or sine theta? Remember this? Yeah, it's cosine theta. Whereas the force down the ramp is equivalent to the weight times sine theta. Okay? So what's my force of friction? So it's going to be mu times the weight. Now the weight is 98. Okay? It's 10 times 9.8 times cosine of 10. That's my force of friction. My force down the ramp is going to be 98 times sine 10. All right, so what's my force of friction? What do we work that out to be? It's probably going to be like close to 20 newtons, I would imagine. 19.3. Okay, 19.3. And this sine of 10 is probably a pretty small number. What is it? 17. Okay, so let's think about now, which way do you, so here is where we have to think about friction. Because friction can go both ways. I want you to think about this for a second, okay? If this value here were greater than this value here, which way would this system rotate? Would it rotate this way or this way? Clockwise, right? And if it rotated clockwise, then which way would friction act? It's always the opposite of what? Opposite of motion. So which way would it act? It would act this way. But in this case, logic dictates that this system is going to rotate which way? Counterclockwise. So this is going to slide this way, which means friction is going to act which way? The same direction as the force down the ramp. Okay? Same direction. So that means that this will have one sign, we'll make it positive, and these two on the other side will be the opposite side. So we'll make both of these negative. Okay? Because we can see that overall this block is going to rotate up. So this block is going to slide up the ramp. Therefore, friction is going to act in the same direction as the force down the ramp. So here's my force down the ramp. Here's my force of friction pointing the same way. So when we get our net force, a lot of work here. When we get our net force, okay, it's going to be the sum of 49 minus 19.3 minus 17. So what is that? 13.7? 12.7? 12.7. Sorry, 12.7. 12.7 newtons. So there's a net force of 12.7 newtons. So now we can go ahead and do the same thing we did before. Figure out the net acceleration. So again, that would be the net force over the mass. So the net force is 12.7. The mass is combined mass, which is 15. So the net force would be what? 0.8 something? What is it? 0.85. Okay, so 0.85 meters per second squared. Okay. That means this block is going to accelerate down at 0.85. This is going to accelerate up the ramp at 0.85. So when we want to figure out the last thing, which is, we'll just say is, last thing here is tension. Okay, again, we can just look at this part over here. So we know that it's accelerating down. So we know that we have tension, we have weight, and we know the net force is the mass of the object times the net acceleration. The object has a mass of 5. The acceleration is 0.85 down. So the net force here would be 4.25, is it? 4.25. 4.25. Down being what sign? Negative. So when we consider what the tension is, we can say, okay, net force is the tension, because we see the tension is pulling up, minus the weight. The net force is down, so keep that in mind, it's going to be negative. So when we rearrange here for tension, it's going to be net force plus the weight. Now, the net force is negative 4.25. The weight is positive because we subtracted it. The weight was 49. So the tension is, what is that? 44.75. And again, does that make sense? Well, yeah, because this is 49. This is 44.75. This is less than this. So yeah, it's going to go down. Right? It's going to go down. Okay? The end.